Magandang araw mga kasipnayan! Welcome to Sir Ocnic's YouTube channel. In this video, we will factor out polynomial functions and we will graph polynomial functions. There are several steps in graphing polynomial functions. First, find the real zeros of the function. Second, make a table of values to find several points. Third, plot the points. And the last one is draw a smooth continuous curve to connect the points. Let us study the end behavior of graphs of polynomial functions. If the degree is odd and the leading coefficient is positive, the graph falls to the left and rises to the right, just like in this illustration. If the degree is odd and the leading coefficient is negative, the graph rises to the left and falls to the right. If the degree is even and the leading coefficient is positive, the graph rises to the left and rises to the right. If the degree is even and the leading coefficient is negative, the graph falls to the left and falls to the right. Let us try to graph the polynomial p of x is equal to x cubed plus 2x squared minus 5x minus 6. The possible zeros of the constant 6 are positive, negative 1, 2, 3, and 6. First, find the real zeros of the function. Using synthetic division, the numerical coefficients of the polynomial are 1, 2, negative 5, and negative 6. Let us try negative 1. Bring down 1. 1 times negative 1 is negative 1 plus 2 is 1 times negative 1 is negative 1 plus negative 5 is negative 6 times negative 1 is positive 6 plus negative 6 is 0. Therefore, negative 1 is a zero of the function. Rewriting the numerical coefficients in polynomial form, we will then have x squared plus x minus 6 equals 0. Factoring this trinomial, we will have x minus 2 times the quantity x plus 3 equals 0. Equating both factors in terms of 0 will result to x equals 2 and x is equal to negative 3. Therefore, the zeros are negative 1, 2, and negative 3. Using the zeros, let us have a table. Negative 3, negative 1, and positive 2 are included in the table, since they are the zeros of the function. Let us insert numbers in between the zeros of the function. The zeros of the function are the x-intercepts of the graph. Therefore, for each value of x in each zero, p of x is equal to 0. Let us insert negative 4, negative 2, and 0 in the table. Using the polynomial function x cubed plus 2x squared minus 5x minus 6, Let us now substitute the values of x in the function. P of negative 4 is equal to negative 4 cubed plus 2 times negative 4 squared minus 5 times negative 4 minus 6. That is equal to negative 64 plus 32 plus 20 minus 6, which is equal to negative 18. Therefore, if x is equal to negative 4, then p of x is equal to negative 18. Let's have p of negative 2. That is equal to negative 2 cubed plus 2 times negative 2 squared minus 5 times negative 2 minus 6. That is equal to negative 8 plus 8 plus 10 minus 6. Or simply, p of negative 2 equals 4. That means that if x is equal to negative 2, p of x is equal to positive 4. Let's have p of 0. That is 0 cubed plus 2 times 0 squared minus 5 times 0 minus 6. Since the multiplier is 0, all the products will be 0. What will remain is the constant negative 6. Therefore, p of 0 is equal to negative 6. Let us now use this pair of numbers as the ordered pairs in plotting the points of the graph of this polynomial function. The first ordered pair is negative 4, negative 18. The second one is negative 3, 0, which is an x-intercept of the polynomial function. The third one is negative 2, 4. We have negative 1, 0, 0, negative 6, and 2, 0. The last step is trace the graph smoothly. This is now the graph of p of x equals x cubed plus 2x squared minus 5x minus 6. Based on the end behavior, if the degree is odd and the leading coefficient is positive, the graph falls to the left and rises to the right. Let us try to graph the polynomial x to the fourth plus 2x cubed minus 8x minus 7x squared plus 12. Finding the real roots of the function, or real zeros, using the synthetic division, the numerical coefficients are 1, 2, negative 7, negative 8, and 12. Let us try positive 2. Bring down 1 times 2 is 2 plus 2, that's 4, times 2 is 8 plus negative 7 is 1 plus times 2 is 2 plus negative 8 is negative 6 times 2 is negative 12 plus 12 is equal to 0. Since we have 4 numerical coefficients still, let us identify another 0. Let us try negative 2. Bring down 1 times negative 2 is negative 2 plus 4 is 2 times negative 2 is negative 4 plus 1 is negative 3 times negative 2 is 6 plus negative 6 is 0. Therefore, negative 2 is also a 0 of the function. Rewriting the numerical coefficients in polynomial form, we will then have x squared plus 2x minus 3. Factoring the trinomial, we have x minus 1 times the quantity x plus 3. Equating both factors in terms of 0 to solve for the value of x, we will then have x equals 1 and x is equal to negative 3. Therefore, the zeros are 2, negative 2, 1, and negative 3. Again, the zeros will be the values of x in our table. So we will then have negative 3, negative 2, 1, and 2. These zeros of the function are the x-intercepts of the graph. Therefore, the values of p of x of each 0 is equal to 0. Let us insert negative 4, 0, and 3 in our table. Using our polynomial equation or function, x to the fourth plus 2x cubed minus 8x minus 7x squared plus 12, we will then have p of negative 4 equals negative 4 to the fourth plus 2 times negative 4 cubed minus 7 times negative 4 squared minus 8 times negative 4 plus 12. Simplifying all the exponents, we will then have 256 minus 128 minus 112 plus 32 plus 12. Or simply, p of negative 4 equals 60. Therefore, if x is equal to negative 4, p of x is equal to 60. If x is equal to 0, let us find p of 0. That is equal to 0 to the fourth plus 2 times 0 cubed minus 7 times 0 squared minus 8 times 0 plus 12. Since the multiplier is 0, all the products will then be 0. What will remain is the constant term, which is equal to 12. Therefore, if x is equal to 0, then p of x is equal to 12. Let us have p of 3. That is equal to 3 to the fourth plus 2 times 3 cubed minus 7 times 3 squared minus 8 times 3 plus 12, which is equal to 81 plus 54 minus 63 minus 24 plus 12. Combining all these integers, we will then have p of 3 equals 60. Therefore, if x is equal to 3, then p of x is equal to 60. Let us now plot the points. Our first ordered pair is negative 4, positive 60. We then have negative 3, 0, negative 2, 0, 0, 12, 1, 0, 2, 0, and 3, 60. After plotting the points, we will now trace the graph. This is now the graph of p of x equals x to the fourth plus 2x cubed minus 8x minus 7x squared plus 12. If the degree is even and the leading coefficient is positive, the graph rises to the left and rises to the right. That is according to the end behavior of each polynomial function. Graph the polynomial p of x equals negative x squared minus x plus 6. Finding the real zeros of the function, we will have negative x squared minus x plus 6 equals 0, which is the same as negative 1 times the quantity x squared plus x minus 6. Factoring the trinomial, we will have negative 1 times x minus 2 times x plus 3. Equating both factors in terms of 0, that is equal to x equals 2, and x is equal to negative 3. Therefore, the zeros are 2 and negative 3. Let us now make a table of values to find several points. Again, the zeros of the function are the x-intercepts of the graph. Since negative 3 and positive 2 are the zeros of the function, the value of each p of x is equal to 0. Let us insert negative 4, 0, and 4 to the table of values. Using negative x squared minus x plus 6, p of negative 4 will then be negative of negative 4 squared minus negative 4 plus 6, which is equal to negative 16 plus 4 plus 6, or simply negative 6. P of 0 will then be negative of 0 squared minus 0 plus 6, or simply P of 0 equals 6. Solving for P of 4, that is equal to negative of 4 squared minus 4 plus 6. That is negative 16 minus 4 plus 6, which is equal to negative 14. Therefore, P of x is equal to negative 14 when x is equal to 4. Let us now plot the points of each ordered pair. We have negative 4, negative 6, negative 3, 0, 0, 6, 2, 0, and 4, negative 14. Let us now trace the graph. This is now the graph of negative x squared minus x plus 6. If the degree is even and the leading coefficient is negative, the graph falls to the left and falls to the right. Let us graph the polynomial p of x equals x times x plus 2 times x minus 2. The given polynomial is in factored form, so we don't need to factor this one out. Finding the real zeros of the function, that will be x equals 0, x equals negative 2, and x equals 2. Therefore, the zeros are 0, 2, and negative 2. Let us now make a table of values to find several points. Remember that the zeros of the function are the x-intercepts of the graph. Therefore, the value of p of x for each 0 is equal to 0. Let us try to insert negative 3, negative 1, and positive 1 in our table of values. Using the formula x times x plus 2 times x minus 2, let us now solve for p of negative 3, which is equal to negative 3 times the quantity negative 3 plus 2 times the quantity negative 3 minus 2, or simply negative 3 times negative 1 times negative 5 equals negative 15. Therefore, if x is equal to negative 3, p of x is equal to negative 15. If p is equal to negative 1, then that is negative 1 times the quantity negative 1 plus 2 times the quantity negative 1 minus 2, which is equal to negative 1 times 1 times negative 3, or simply positive 3. Let us try to solve p of 1. That is 1 times 1 plus 2 times the quantity 1 minus 2. which is equal to 1 times 3 times negative 1, or simply negative 3. Let us now plot the points in the Cartesian coordinate plane. We have negative 3, negative 15, negative 2, 0, negative 1, 3, 0, 0, 1, negative 3, and 2, 0. Tracing the graph of the given polynomial function, remember, if the degree is odd and the leading coefficient is positive, the graph falls to the left and rises to the right. Let us now summarize what we have discussed in this video. The steps in graphing polynomial functions are: first, find the real zeros of the function, make a table of values to find several points, plot the points, and draw a smooth continuous curve to connect the points. The zeros of the function are the x-intercepts of the graph. The number of turning points of the graph of a polynomial function is 1 less than its x-intercepts. Let us now check your knowledge. Try to graph the following polynomials. Do not forget to pause this video while you are doing this activity. Let us now check what you have done. Graph the polynomial p of x is equal to x cubed plus 3x squared minus 4x minus 12. Let us first find the real zeros of the function. Using synthetic division, the numerical coefficients are 1, 3, negative 4, and negative 12. Let us try negative 3. Bring down 1 times negative 3 is negative 3, plus 3 is 0, times negative 3 is 0, plus negative 4 is negative 4, times negative 3 is equal to positive 12, times negative 12 plus negative 12 is equal to 0. Therefore, negative 3 is a zero of the function. Rewriting the remaining numerical coefficients, that will be x squared minus 4. Using the sum and difference of two squares, the factors are x minus 2 times the quantity x plus 2. Equating both factors in terms of 0, we will then have x equals 2 and x equals negative 2. Therefore, the zeros are negative 3, 2, and negative 2. Let us now make a table of values to find several points. Take note that the zeros of the function are the x-intercepts of the graph. Therefore, p of x of negative 3, negative 2, and 2 are all zeros. Let us insert negative 4 and 0 in our table of values. Solving for p of negative 4, using x cubed plus 3x squared minus 4x minus 12, we will then have negative 4 cubed plus 3 times negative 4 squared minus 4 times negative 4 minus 12. That is equal to negative 64 plus 48 plus 16 minus 12, which is equal to negative 12. Therefore, if x is equal to negative 4, p of x is equal to negative 12. Let us solve p of 0. That is equal to 0 cubed plus 3 times 0 squared minus 4 times 0 minus 12. Since the multiplier is 0, all the products will then be 0. What will remain is the constant term, which is equal to negative 12. Therefore, if x is equal to 0, then p of x is equal to negative 12. Plotting the points on a Cartesian coordinate plane, we will then have negative 4, negative 12, negative 3, 0, negative 2, 0, 0, negative 12, and 2, 0. Let us now trace the graph. This is now the graph of x cubed plus 3x squared minus 4x minus 12. If the degree is odd and the leading coefficient is positive, the graph falls to the left and rises to the right. Graph the polynomial p of x is equal to x times x plus 3 times x minus 3. Finding the real zeros of the function, since the function is in factored form, equate all factors in terms of 0. That will be x equals 0, x plus 3 equals 0, or simply x equals negative 3, and x minus 3 equals 0, or simply x equals positive 3. Therefore, the zeros are 0, 3, and negative 3. Let us now make a table of values to find several points. Remember that the zeros of the function are the x-intercepts of the graph. Therefore, the value of p of x for each 0, negative 3, 0, and 3 are all zeros. Let us insert negative 4, negative 1, and positive 1 in our table of values. Using the equation x times x plus 3 times x minus 3, let us solve for p of negative 4, which is equal to negative 4 times negative 4 plus 3 times negative 4 minus 3, or simply negative 4 times negative 1 times negative 7, which is equal to negative 28. Solving for p of negative 1, we will then have negative 1 times negative 1 plus 3 times negative 1 minus 3, which is equal to negative 1 times 2 times negative 4, or simply positive 8. Therefore, if x is equal to negative 1, p of x is equal to positive 8. Solving for p of 1, we will then have 1 times the quantity 1 plus 3 times the quantity 1 minus 3, or simply 1 times 4 times negative 2. P of 1 is equal to negative 8. Therefore, if x is equal to positive 1, p of x is equal to negative 8. We may now plot the points of each ordered pair on a Cartesian coordinate plane. The first point will be negative 4, negative 28, negative 3, 0, negative 1, 8, 0, 0, 1, negative 8, and 3, 0. Let us now trace the graph of the polynomial function. This is now the graph of p of x equals x times x minus 3 times x plus 3. Take note that if the degree is odd and the leading coefficient is positive, the graph falls to the left and rises to the right. Thank you for watching Sir Ocnic's YouTube channel. If you think that this video is a big help, hit like, feel free to share, and do not forget to subscribe. Always have fun in learning math. Enjoy learning! Thank you and God bless.